We have in the previous tutorial discussed about the model-based approaches, namely linear trend, exponential trend, quadratic trend, and we have looked at additive seasonality, multiplicative seasonality, etc. Today, we are going to discuss about data-driven approaches, within which we will get started with moving average, then we'll look into simple exponential smoothing, double exponential smoothing, and winters. We will look at which of these techniques gives us the least error, and then we will build that final model for forecasting. Alright, so let us load these mandatory packages to proceed with forecasting. FPP is one forecasting package. ReadR will help you read the CSV and Excel files. You have time series package. You have smoothing, because moving average and exponential smoothing are smoothing techniques, and you have forecast package. I would request you all to always go here under packages. Just look at these. What does FPP mean? Forecasting principles and practice. Just click on that and there will be a description file. Read this description file without fail. You need to just read these things. So no matter what package you deal with, just briefly read the description. For example, if it is read tabular data. If it is T-series, time series analysis and computational finance. For that purpose, we use this particular package. Just go ahead and read the description file. Nothing much. Yeah. You will come to know on which year, when was this package. So this was packaged on 20th Feb 2017. So this will have the most recent upgradations in the space of forecasting. Smooth, it has forecasting using smoothing functions. So if you click on that description file, you'll get to see. So the set of smoothing functions used for time series analysis and in forecasting. Currently the package includes exponential smoothing models, SREMA in state space form, plus several simulation functions. When was this launched? 18th March 2017. Oh, so you'll have the most recent information as part of this smooth package. And finally, we have forecast. Forecasting functions for time series and linear models are available. So always you have to just give a glimpse on what kind of package you're dealing with. All right. I'm using a function read underscore CSV to read a CSV file. And within the brackets, if I give this function which says file.choose, it is going to pop up another window wherein you'll be given an option to choose that specific file. So let me run that. And where are we? Within the forecasting, we are dealing with data-driven approaches. So the data set that we will be looking at is aviation data. If I click on this, you get to see that there are 42 entries, quarterly data, quarterly sales data of aviation. So this is the data set that we will be dealing with. But if you look at the class of this aviation, it says that it is a data frame, right? Table, data frame, table, it's a data frame, right? It can be any of those. So we'll stick to this because we are familiar with data frame. But when it comes to time series, especially when you are implementing your data-driven approaches, you have to ensure that the data is in time series format. Right? So this variable that we have sales, we're converting that to time series data type. So aviation dollar sales will refer to that specific column. And I'm saying, hey, I want to convert this to time series and frequency is 4. So 4 quarters will capture, 4 quarters is equal to 1 year, and 1 year will capture seasonality. So I say frequency is 4. And using the assignment operator, we are assigning it to an object called aviation underscore data. There we go. You can just run this and see what is there in that. So you have the quarterly data in time series format. Now we have done the pre-processing. Here the pre-processing means converting the data into time series format. Then you need to divide the data into training and test. So based on the same logic of having 4 data points as part of your test, because this is quarterly data, seasonality is 4. Hence we are taking 4 data points and assigning it to test. So aviation underscore data, I want 39 until 42, the last 4 observations to be part of test. Now these two are in numeric format. If you see here, these two are in numeric format. This is in time series format. So we need to convert test data and train data from numeric to time series. Simple, the same logic applies here. So you say time series, training data, convert training data into time series with a frequency of 4 because we have quarterly data. And using assignment operator, I assign it to an object called train. Test data, now you see here the train data changed to time series. Now the test data also should be converted to time series with a frequency of 4 because we have quarterly data. And using this assignment operator, we assign it to an object called test. Let me run this. There we go. Test also is now time series. Great. Now let us plot this data, time series data. Since it is time series data, it will anyways give you a line chart. There we go.